The biggest mistake teams make with tactical AI is buying accuracy and forgetting the decision tree. In high-stakes environments, what matters is whether you can inspect the branches, audit the pruning, and trust the uncertainty. Probability tree reasoning is a practical way to think about choices under pressure. You start with a state estimate, you list actions, you map possible outcomes, and you attach probabilities and losses. Then you prune the tree so it fits your time and compute budget. A tactical decision AI is the system that does this repeatedly under partial information and still leaves behind a reviewable rationale. As of 2026, most real systems are not end-to-end autonomous commanders. They are hybrids. They mix hard rules, probabilistic scoring, and machine learning for state estimation. Full tactical authority by the machine is still uncommon in high-stakes domains, mostly because governance and verification are harder than the modeling. That leads to the first high-impact finding. Explainability is not a nice-to-have model feature. It is a system requirement. Operators do not need a mystical confidence score. They need compact, testable reason traces across the branches. They need to see which constraints fired, which evidence mattered, and why certain options were removed. If the system cannot expose that, it is not decision support. It is just an oracle you cannot question. A useful way to frame it is the explainability surface. That surface can include the graph itself, short summaries, counterfactual deltas, and explicit constraint hits. The point is not to generate more text. The point is to make decisions replayable. When the decision goes wrong, the organization must be able to reconstruct what the system believed, what it considered, what it pruned, and what it recommended. Here is the second finding, and it is counterintuitive. You should treat tactical decision AI as a measurement and governance program, not a model purchase. In other words, you are not buying a brain, you are buying an instrument panel, plus the test bench that keeps it calibrated. Calibration integrity becomes a contract, not a vibe. Calibration means the mapping between stated confidence and observed frequency under repeated comparable conditions. If the system says 80% confidence, it should be right about 8 times out of 10 in comparable settings. Miscalibration is not a small error. It changes how humans and downstream systems take risk. So you require routine calibration reporting and drift alarms. You also separate tasks by class, because a recommendation under low tempo is different from one under high tempo, and you measure calibration per task class, not as one blended number. The third finding is about evaluation, and it will matter to every capital allocator listening. The right question is not, did the AI win a benchmark? The right question is, what is the effect size, across scenarios, across operators, with uncertainty intervals? Tactical systems live or die on distribution shift. A single impressive demo can hide a brittle policy that collapses when the base rates move, when sensors fail, or when adversaries adapt. That is why practical evaluation leans on cumulative, quantitative reporting. Effect sizes matter, repeated measures matter, mixed effects models matter, because you are comparing performance across many scenarios and many human operators and many environments. You want to know whether the system helps reliably, not whether it helped once. This is also why general scientific computing stacks show up in the real workflow. Simulation, optimization, statistical validation, and reproducible analysis pipelines are the work, not the afterthought. If you cannot replay scenarios, version the harness, and reproduce the analysis, you cannot govern the system. You cannot even argue about it productively. Now the fourth finding, and it's where many programs quietly fail. Pruning is both necessary and dangerous. Every real probability tree blows up with depth. You will prune branches to meet latency budgets, but pruning can delete exactly the branches you most needed to keep. Low probability, high impact outcomes are often the ones that change strategy, trigger escalation, or avert catastrophe. So pruning cannot be a hidden optimization, it must be an auditable policy. Every prune operation should be logged, with explicit criteria. Some branches must be protected. If a low probability branch has a high impact loss, it should not disappear just because compute is tight. If it must be removed, the system should be forced to record a high impact justification that a human can review. Latency makes this more urgent. Decisions have expiry windows. A recommendation that arrives late can be worse than none. Operationally, you end up enforcing P95 and P99 decision latency budgets, and you separate recommendation time from authorization time and from execution time. You also define degraded modes, because evidence streams will be incomplete. Sensor loss is not a corner case. It is a normal condition in contested or messy environments. When sensors degrade, the system should not present false precision. It should widen uncertainty explicitly and adjust which branches it can responsibly score. If the system continues to speak with the same confidence, it trains operators into automation bias. That brings us to the fifth finding, and it is mostly about accountability. The core governance move is to separate recommendation from authorization. A tactical decision AI should output ranked options, uncertainty, constraints, and an audit trace. It should not silently slide from recommend into decide. That boundary must be enforced by authorization primitives. In practice, that means roles, dual key patterns where appropriate, and time-bounded authority tokens. The organization should be able to say with evidence who is allowed to do what, when, and under which constraints. That is not just compliance theater. It is how you prevent drift into unowned autonomy. Auditability then becomes concrete. You want immutable, replayable traces, state snapshots, the branch graph, prune reasons, final recommendation sets, operator actions, tool and model versions, input evidence summaries. If an independent team cannot reconstruct the episode from logs, you do not have a safe decision system. You have an anecdote generator. Several risk modes follow naturally from this framing. Confident but wrong branches are obvious. More subtle is adversarial manipulation of evidence. If an adversary can steer observations, they can steer the tree. That is why provenance checks and adversarial injection tests matter. Another subtle failure is silent pruning of catastrophic branches. Yet another is audit log gaps, where the story cannot be reconstructed, so nobody can learn. All of that rolls up into what you should actually buy, and what you should actually build internally. Procure branch graph visibility and auditability as primary deliverables, not just top-line accuracy. Contract for evaluation rigor, including effect sizes and uncertainty intervals across scenario suites. Budget for scenario engineering, red teaming, and continuous monitoring, because those are ongoing operating costs, not one-time integration work. A minimal acceptance mindset also implies a set of scenario tests you run again and again. You perturb base rates to see calibration drift. You remove sensors to see whether uncertainty becomes explicit. You inject spoofed reports to see susceptibility and detection. You change goals mid-episode to measure replanning time and whether old branches expire. You seed rare catastrophic outcomes to test whether pruning retains critical branches. Then you do post-action reconstruction to prove the logs are actually usable. One last long horizon note. Formal methods will likely become part of assurance in the 2040 to 2100 band, especially for constraints, invariance, and authorization logic. But world modeling and sensor fusion will remain empirical. The near-term win is not perfect proof. The near-term win is disciplined measurement, calibrated uncertainty, and decision artifacts that humans can audit at speed. If you remember one line, make it this. In tactical AI, the tree you can audit beats the answer you cannot.